Trupti. It is indeed a pleasure to conduct this session with you all. So, and today's topic is very interesting topic, is application of data science in supply chain management. So, you know that data is the new oil. So that's how organizations are now getting into the digital mode. Maybe it started with about 7 years back, but increasingly corporations are looking to get into the digital mode because they can leverage. There is a technology available now. There is computing resources available now. There is the basic infrastructure for communication available now, which is all making it possible. So we are at a very interesting juncture in time where we will see a lot of disruptive innovations take place, and this will be because of the way we use data, the way things will happen in the digital economy, in a digital company. That is so we are at the cusp of a era of change which is going to happen, though it may not be immediately visible, but over the next 5 to 10 years, substantial changes is going to happen. So, for example, we will have autonomous driven cars. Okay, so those cars will be battery operated. Gone will be the IC engines. So no more smoke or anything. From a technology point of view, those cars will be self-driven. You don't need to drive your car anymore. You just have to request for a transportation service from your home to your office, or maybe to wherever you want to go, and a car will arrive at your place, much like you order a Uber or a Ola these days. A car will come to you. It will be driven by a robot, or it will be automatically controlled, driven, and you will just go to your place and then release the car. It will be ready for another passenger. So that's going to be the future. Maybe not now, 10 years or 20 years, we are going to see all these things happening. So with this small introduction, we would jump into the session today. I know it's about 90-minute session. So I would love to talk more about it. So, but given the time constraint, that is what we will do. So I would encourage you to if you have any questions or queries in between which intrigues a discussion, please raise it and we will discuss on the way. And I would also like to know your expectations. If any of you have, though I have prepared my slides and and then I'm going to present them, and then we're going to discuss in the next 90 minutes. But if there is any expectation from your side, you may share it now, and I will see in what way it can be addressed in this session, or maybe through an email or through different modes of communication. We can try to address those. So I would just allow you to maybe tell me if there is an expectation out of this particular session, then I will try to incorporate. Yeah, anyone wants to share, or wants me to discuss some topic, or has any expectation out of this course? So of course, apart from you completing your certificate requirements and all that anyway will happen by end of tomorrow. But if you want, we can definitely address those. And I'm a little poor in these chat boxes. So if you have anything, you can maybe share it. I can see that. Can we relate the real world example that Jitendra Barik has requested? Yeah, we will definitely have a lot of real world examples. Anything more? Anyone? Or we can get started. Okay, let's get started. If you get if you get any, if something strikes you in between, or if you want to discuss, we can do that. So what I'm going to do is I'm going to present my screen now. So, and then I have some slides and we can go over them. Okay. So I'm unable to share my screen. So Professor Trupti, do we need any permission, or it's going to, I'm not being allowed to present. Okay, I think I got it on now. So sometimes these technical glitches. Can you see my screen, please? All of you, can anyone confirm that you're able to see my screen and the slides?
Yes, sir.
Okay, slides are visible. Thank you so much. Okay.
Yes, sir. Yes, sir.
Okay. So here we go. So today's topic we will cover in three different aspects, from three different aspects. One, we'll quickly review a little bit about what is data science, and then we will also have an overview of what is supply chain management, and then the third session will be on applications of data science in supply chain management. So this is the order in which we will proceed. So let's talk about a little bit about data science. So you've been already hearing a lot of data science related stuff in the last 3 years. You must all be aware of it by now. But I will try to maybe give little bit perspective, and most of these are from a perspective of today's session is more of a perspective of trying to take managerial decisions. Okay, we'll not get into a lot of all these optimization, heuristics, machine learning, AI. So we are not going to get into the nuts and bolts of those stuff, but we will try to look at the applicability and where managerial decision can be taken. So that's the focus for today's session. So so data science. So what is data science? So it's an emerging field, fairly new field. It's not that we never used to do data analysis. Previously, if you look at, people used to do a lot of data analysis, and there were analysts also, and there are a lot of applications. Even otherwise, the census. If you look at census, every 10 years, government of India does a census. So it collects data and does a lot of analysis from that data to be able to provide services to the citizens of the country. So it is not that data science has emerged yesterday or 5 years back or 2 years back. So the naming data science, the term data science has emerged now, but it was there initially in some form of data analysis, because once you collect some data, convert it into useful information, then use it. That's what it was being used. But these days it's being used in a manner where you automate certain things, you use a lot of computing resources, you use a lot of models, algorithms to predict. So that's where the difference comes from. So it's an emerging field, and it is a confluence of three streams. One is computer science, technology, the other is statistics, and third is the application domain it is being used. So for example, if you want to use it in a hospital, data science would be different. Maybe you want to treat a person who is suffering from a disease, okay, and you want to see what is the prognosis, or you want to see some x-rays, and you want to see to the extent of extent to which the disease is spread. So there are a lot of diagnostic machines which are being used to capture those data. Say, for example, a simple X-ray machine to a CT scan machine. We have various things, or a simple thermometer to measure the temperature. So a lot of things which are there to and applicable in a medical field. Similarly, if you go and apply it to a automobile industry, a data science would be different. Similarly, if you go and talk data science to cephalogists who predict poll results, say exit poll, Bihar exit poll. No, none of the exit polls got it right, but that doesn't mean there is no data science behind it. So it can be applied to a lot of domains. So in every walk of life, right from the government of India, which provides public services, till a private company, we have the application domains. Application domains are wherever we can use it. Okay. Now, how does data science do all these things? So it uses statistics, machine learning, heuristics, optimization models, etc., and applies it to the application domain in whichever area you want to work. It applies in that. And what is the purpose of it? Many times it is for only description, explanation, prediction, and action taking. So if you look at any of these, they will fall in these categories. Okay. Say, for example, you have these days there are cameras fitted in traffic signals. Okay. So if a car or a scooter jumps a traffic signal, red light, then the camera is supposed to click a picture of the vehicle with the number plate, and so that is a method of capturing who has jumped a signal. Now it doesn't stop there. Say, for example, you want from the it's connected, obviously it's connected to a internet network, so it sends the data immediately to a database. So, and based on the registration number of the vehicle, the record of the owner is pulled out, and corresponding to that, you find an address where this person resides. So immediately a challan can be issued electronically to the person who has violated. So if you look at this, there are a lot of things which has happened very fast. One is a camera has clicked a picture. So there is some data which has been collected, and based on that data, the number plate. So there is a number. Now there is no human being. So there is, from the picture, you will have some kind of a artificial intelligence to be able to do a recognition of numbers, patterns, faces, etc. So this number recognition, pattern recognition, if you look at it, Facebook had said 10 years before and 10 years after, that kind of a challenge they had shared. So what were they doing? They were trying to tune their algorithm to be able to do a recognition of face and patterns. So similarly, now from the registration number of the vehicle, the numbers can be read. Now, once the number is read, then it is, so it's a picture. Picture is, from there you get the number. From that number, it is digitized, and that information is queried in a database to find who is the owner and where he resides. Okay. So based on that, if there is an email or a phone number, you can send it directly e-challan, or you can also, if it is not available, you have the address. Address is mandatory field in your RC book. It will be able to dig out that information and print a challan and send it to your office or home. So if you look at it, now we have taken a decision, taken an action, because there is a playbook. The playbook says that, okay, if this happens, if there is a traffic light violation, you need to send a challan. Now the challan can be sent. So we have recorded, we have used internet facilities to hook up to a database. From the database, we were able to pull out the record. And for pulling out the record, we did a pattern recognition for the number. And based on that, we were able to find out who that defaulter was. So similarly, it can be used for description. Say, for example, air quality index. Now, air quality is monitored almost at every place, and then we see that alarming level of air quality in Delhi and NCR region. So what happens there? So there are probes which collect the particulate matter and find out what is the NOx and what are the different components. And based on that, that information needs to be displayed to citizens. So there are huge boards at different areas where they say air quality, and they give you a green, yellow, or orange kind of a light which shows, and then they tell you what is the value of the pollution or how clean is the air. So there we get a description of what is happening. So it is not to do any action, but it is just to make people aware. So something is happening and you be aware of it and take proper action, whatever based on the information that has been provided to you. General safety, health, safety guideline for people at large. Now, so the third is what has led to the emergence of data science. Now we discussed in the previous example of the red light, traffic violation red light. We have seen that we first need sensing devices. These sensing devices can be a camera, can be a RFID tag, can be a sensor, pressure sensor, or a thermal sensor, or maybe on your machine, CNC machine or other machines, you have sensors which tell you how much the tool is worn out and when it needs to be replaced. So there has to be some kind of a sensing mechanism, and these sensing devices are available readily these days, and these are not very expensive also. Now once you have sensing devices, you will be able to use it in a variety of ways. The second is, once you capture this, what do? So obviously you will send it to some kind of a central repository database, or you will just pass that information to the user if it is a local level. Say for example, a worker is working on a machine and he needs to change his tool. So we don't need to send it to a database immediately, but we need to show it on his screen saying that, or some kind of a light should come on saying that no, the tool needs to be changed. Okay, so that the operator can go and change the tool with replace the tool with a new tool and continue working. Or if it needs to be also recorded, you can also record that, send it through your LAN or Wi-Fi to a corporate database where you say that okay, this signal has come for a tool change. So while you give that light flash to the operator to change it, but there is also a record being kept saying that this is the machine sent data for tool change and a tool change has been made. Or say for example, if you have these printers where the ink or cartridge is going to run out, it will flash you saying that only this many papers it's getting depleted and this is the amount of ink which is remaining for you to print, so that you are aware. Okay, so there are some sensing devices. Then you have a mode of getting the data into a centralized database, and this is where that storage capacity comes into picture. So you'd remember that if you have opened a mail account, Gmail or Yahoo or any other mail account, say early 2000 or 1999 and all that, when we opened, we used to get 1 MB or 2 MB storage. Now they made it into 15 gigabyte of storage for everyone, and they're not asking any charge. So which means that the storing capacity has increased, and it has also become cheap. You can buy it also. So I'm talking about a general user, about a Gmail account or a Yahoo account or any other mail account where it's given free. But if you go and buy a storage device, also external hard drive for 2 terabyte is maybe about 6,000, 7,000 rupees. So these storing capacities have reduced. This because of technology, improvement in technology. You're able to pack more number of transistor per square inch of a semiconductor chip, and that's how it has increased. So similarly, the data usage capacity. So the amount of data that is being generated in the economy by people and all, you and me, has also increased tremendously. Okay, like the Moore's law, which says that computing capacities will increase every or double every 18 months. Similarly, there is the Kreiber, or there's another guy which law which says now the data being produced, that is doubling every 12 to 14 months. So while your computing power is increasing every 18 months, your data is doubling every 12 months. So it means that the rate at which we are generating data, if we were to process all the data, we are still lagging in computing uh, capabilities, storage as well as prowess. Of course, there are quantum computers which are in the works. Those will also emerge maybe in next 10 years. While Google has said that they have a quantum computer, no one believes them so far. So quantum computing will come, and that is going to astronomically change the capabilities of computing. So till that point, no, there is a bridge, and there are issues with respect to huge amount of data. So that is where a lot of algorithms, how to take large amount of data and reduce or get to the crux of what we are looking at, how we can summarize, how we can do data reduction and generate insights. Those are being done by various ways, big data, Hadoop, and other technologies, and a lot of machine learning, AI being used there, Pythons and all that stuff are being used. And in the meantime, this, you must have heard about the term called Industry 4.0. So this Industry 4.0 is nothing but people are referring to it as the fourth industrial revolution. So if you look at it, all these things have started from the industrial revolution. So there are phases which people have said that Industry 1.0, 2.0, 3.0, and 4.0. So currently we are at a 4.0. So this 4.0 appeared somewhere in some write-up in Germany in 2012. Okay, so if you technically go, we are about 8 years into Industry 4.0, and this Industry 4.0 has got a bunch of technologies which has been put. There are many sources where you can get this, but there is a big list of about 50 odd technologies which are being called as Industry 4.0. However, the predominantly the big is about 7 to 8, which can be called the real movers and shakers in this Industry 4.0, and those are Internet of Things, big data, blockchain, robotics, 3D printing, autonomous vehicles, machine learning. So these are all certain things which have emerged in the last about 5 years or so, and they are disrupting things like anything. So this has led to, so previously we knew that okay, there is data can be used, but now the rate at which data is being created, there's a lot of flooding of data. You might be getting a lot of WhatsApp messages, your SMS also would be flooded by a lot of realty and other people who are making offers that you buy this, you get this. So suddenly you find that your phone has become a source of big information of data. Now, most of the time I ignore, I don't want this data, someone bothering me whether I need a loan or I want to buy a house, I want to buy a car. So some data are not important. Some data, when I'm doing a financial transaction, I need to get the OTP. That is a useful information for me. So people have to now figure out. Now, previously, when I worked in my first job in Ashok Leyland, so my boss used to have a secretary. Now that secretary's job was to filter out the calls my boss was getting, okay, and filter out a lot of other stuff, so that time of boss can be utilized. Similarly, we need some kind of a filtering mechanism given today's data explosion. We are all being mindlessly bombed with a lot of data which probably we don't want. So there has to be some kind of a filtering mechanism, otherwise we will just be wasting our time in reading something which we should not be reading. Okay, that's besides the point. What should and what should not happen. But let's look at what is how data is being meaningfully used. So one is anyway, we have through a couple of examples we have seen how data is being used. So we'll run a little fast with this slide. So this says that first is we have to acquire data. Now without data being acquired, we will not be able to do anything. Second, we need to have a database which can be physical in your premise or cloud, and we need a mechanism to connect the data which has been collected to this repository. And then there is a data preparation and cleansing. So this is where to make any useful inference out of the information, convert data into information, a lot of preparation and cleaning work needs to be done. It's being done in stages and all that. So the gating process and staging in which all this preparation work is done. But it's very important. If it is not cleansed, not proper data, so if you put in garbage in, then you get garbage out. So you get GIGO. So this is a very important part. Mostly you will find that this is not there in books, and most people do not talk about the cleansing of data. But in my own experience, wherever we have gone to implement supply chain solutions and all that, and provide them with the capabilities they are asking for, invariably we have hit into this kind of a data cleansing. So end of the day, we end up cleaning the data of the customer so that I'm able to show what is their plan. Otherwise, whatever plan I show, they say that this is not a good plan. Then I always go back and tell, look, your input data is not correct. Now, if your input data is not correct, I cannot give you a good plan. So they say, okay, we will clean the input data. It takes time. So we go and we see, okay, let's sit with your guys and we'll help you out and we'll clean the data. So many times we clean a data, or we say that, okay, whatever ERP system you are having, let the data reside there. You create a temporary staging area, another database we create with whatever we need, and then we put pipelines. We put plumbing into it and pull out the relevant data, clean it, and keep it in a format which I can use it for planning. So this data preparation and cleaning takes a lot of amount of time. Okay, but once you do it, it's only matter of plumbing, right? You just put the pipes properly and you put proper filters and checks. So it's matter of pulling every at whatever desired frequency. So if it's inventory, then probably they'll give you every batch in the night, you have to pull the inventory. If it is master data of products, then okay, if a product is going to be, so it's only one time job, and then periodic updation, like product is getting phased out, then you have to say that, okay, this is the end date of the product. Or if a new product is getting introduced, then you have to add a new product and all that. So for master data, it is periodic. For transaction data, there is a periodicity depending on what kind of a data it is and how sensitive it is. So, but that part needs to be done. Otherwise, we are stuck somewhere. The next is the data analysis. So we have seen different, and we'll also see in forthcoming slides what kind of analysis is possible. Then there is a visualization, data visualization. Many times it so happens that data is there, but in the raw form, if it is not properly grouped and all that, intuitively we are not able to, human mind is not able to comprehend that. So if you give a pictorial view of what's happening, say for example, if someone is saying that reading a list of, say there are 100 people and who has passed and who is first division, second division, or whatever grading has happened. Based on that, if someone is reading a list of 100, probably it will take an hour, and after that I will not remember anything. But if it is summarized saying that, look, there are 95% of people have passed, okay, in that top 20% are in grade or whatever, A or A plus, whatever. And if you make it some 4 or 5 categories, then it gives a nice picture for me to be able to comprehend, okay, oh, this is what the data is saying, rather than getting into the raw form of the data. So visualizations are in fact graphs and charts and maps, and then you create some dashboards. Sometimes, if it is going to be a repetitive one, then you prepare some canned reports, which can be, the format remains same, only the underlying data changes every day. So when you come and see, you are able to see, okay, what's showing. Decision making can be automated. So based on data, so ultimately, why are we doing all this? So somewhere we have to make sense out of the data. So that is where this is the most important part. All these things, data acquisition, repository preparation, cleaning, all this has been created for some decision making. Now, what is the decision that I need to make? So there are, depending on your business context, the decision will be different. If it is going to be in strategic nature, you can make strategic, tactical, or operational decisions. Okay, and certain decisions can be automated. So certain operational decisions can be automated. So for example, you want to run the payroll for a particular month. So if employees are there, attendance, leave register, on all are present, and the grade of the employee or pay scale is already fixed, then it's a matter of, you schedule it saying that on every end of the month, say 30th or 31st, and if it's going to be February month, then it is 28th or 29th, depending on leap year. The computer will know, and at the end of it will run the payroll. So that's kind of a decision making. Okay, so it has collated a lot of inputs, and based on that, it is already told. There's nothing, I don't need to go and sit down and calculate myself for myself. Maybe people were doing it for ages when there were no computers, and the accounting department was the most sought after department, because they control a lot of your pay, salary, bonus hikes, and all that stuff. But no more, it's all automated. So if there is, so you manage by exception. If there is an exception, there is an error, then only you go and check, otherwise you don't. But there are certain things which are manual in nature. Suppose you want to know, I'm a businessman, I have three plants for my current business, and I'm looking at expanding. I want to put a fourth plant somewhere. Okay, can I make it automated? No, of course not. I will first look at all the information that I need with respect to is about whether I have the markets, whether I have the products, whether I have people, whether I have suppliers, whether land is available, and what will be my transportation cost. I will look at, I will first like to see some kind of a simulation of my entire enterprise in a digital way without even spending anything. Okay, I want to see how my operations look like. Okay, I would like to look at what would be my cost, one-time cost for putting up that plant, and which will require no capex. What is the amount of money that needs to be sunk in, and my operational expense, day to day, how much I will be spending. So on a monthly basis, and quarterly basis, and yearly basis, what will be my total revenue, what will be my total cost, what will be my profitability, what will be my customer service levels, what will be my market share. So these are certain things which I will take into consideration. So the ability of computers or artificial intelligence is not so much to be able to make those decisions at this point in time. So it has to be taken by manually by the CEO and board of directors, whether they want to go ahead or not, because a lot of resources need to be committed. Okay, and unless they see the benefit out of it, they are not going to commit those resources and time. Okay, so some of these examples I have already covered. If you look at it, if you look at it, there's a top half and bottom half of those examples. Okay, in slide 4. Can anyone tell me what is the difference between the examples I have listed on the top half uh, versus the bottom half? There is a certain logic why I have kept it like that. Hello, am I audible? Hello. Yeah. So can anyone share?
Sir, in the chat box,
Yeah.
sir, in
No,
the
I'm
chat
not.
box, they are responding, sir. Participants are responding in
Okay.
the
So
chat
there
box.
is no. Okay, people are not talking. Is it okay? I'm not able to see the chat box when I'm presenting. So okay. So what we'll do is maybe pause a little bit to check the chat box, and then proceed. Let's look at the chat box before we come here. Okay. Okay, cryptographic algorithm for network traffic. Okay, there is one question. Methodology to use to capture number plate from picture. Okay. Data acquisition, and second is processing. Okay. Okay, so not much here. We'll try to take these questions time permitting. Okay, so if you look at it, the first top group of examples here, like camera and traffic light, fast tags, for your vehicle to not stop at the toll booth and then just go, the money gets deducted, you just do zip through. So these are all something, or Alexa, or maybe this ride sharing, Uber and Ola, or maybe pensioners submitting their life certificate through Aadhaar and their biometric fingerprints. So these are all something which are new, which were not existing about 5 years back. But if you look at it, and they've been all using some amount of data science somewhere. Okay, but if you look at the bottom half, sensors, actuarial services are for example, for writing for your insurance purpose. So when you take insurance, or for your house or car or yourself, no, there is someone who is underwriting. So there are underwriters who take up this work, and they try to look at what is the risk of giving that insurance to for these products. Okay, so based on the risk and reward, they come up with some value. That is how the insurance premiums are fixed. So these are all these people have been making use of data and models much before all these data science came into picture. Census is also, if you look at it, not now, but even during the times of kings and rulers and monarchs and all that, they used to have census because they wanted to collect the taxes from people. Okay, so it is there. So this counting, keeping record is there from time immemorial. Okay, weather forecasting. So if you look at it, we know the temperature, we know the humidity, we know whether it's going to be rain or something is going to happen. So these things are already known, and lot of data is being captured. And these days the prediction or accuracy is pretty high, because supercomputers are being used for weather forecasting. And if you look at the disaster management, is also predicting a lot of cyclones pretty accurately in India. If you look at last 7 or 8 years, so that the rescue operations, or maybe the preventive measures of moving out people from coastal areas or different places, is less loss of life and property. So people make advanced planning and are more prepared. So these things are already, were already happening, okay, before the data science kicked in, the terminology data science kicked in. We have been hearing about earthquakes from many. Probably when I was a small kid, I used to hear about those earthquakes and all that, and we knew that at different places in the earth, the seismometers have been placed, and they are continuously tracking what's happening with the vibrations on the earth. Similarly, you have rainfall measurements, exit polls. So all these are data is being captured, and the data capture, after it is being captured, it follows the process of uh, keeping it in some database. Or if not, previously there used to be long records It used to be physical books and records, and and then you used to do some analysis on them to be able to see how it can be used for managerial decision making. Okay, this is one more example of Chandrayaan 2. So we were all hoping that it will be a soft landing on moon, and then we will be able to have the Pragyan, the rover, come out and all that. Unfortunately, last 2 minutes we didn't know what happened. So, but then after a year or so, this is a news item from 2nd August 2020. So NASA creates, so they are taking pictures of surface of moon, and they had released a dump. So there was data capturing which has happened by NASA, and then they placed a dump. And there's this techie Sanmugam from Chennai. So this guy, he has taken a lot of interest into that, and he wrote a lot of machine learning algorithms, AI, to be able to go through those data and point out, okay, point out saying that there is a physical distance between the lander and rover, and he was able to show that there are tracks of the rover, which means that in the 1 year past, the rover has moved some distance, which makes it so from which we can infer that even after a hard landing, the rover has probably survived and has moved some distance. Okay, so this is not possible without use of data science. First is you capture data, you analyze data, you prepare, then use your own methods of extracting what is the truth or information out of the data, and and show it. Even ISRO was not aware of it. They said, okay, we're going to probe it and all that stuff. So 4 months on, I have not followed what has happened, but at least Shanmugam did a fantastic job of able to get this. So if a common guy like Shanmugam can do it, then it opens because we have the capabilities now, we have the technology now, so we can do we can deal with a lot of data and make them speak in different ways. Okay, so we just need to take one area where we know the domain, where we know the application or business domain, or what is to be done, and if we have expertise in the area, we will be able to extract a lot of understanding about phenomena based on the techniques of data science. Okay, so this one is another one. This is for some kind of social collaboration, how it has been used. So in Mumbai, this torrential rain happens every year, and then the roads get battered, and there are potholes which happen and all that, much to the annoyance of citizen of the country. So there has always been people are generally, they don't want potholes and want smooth roads, and so BMC took a initiative of pothole challenge. They said that it's called a pothole challenge. If you go and find a pothole, physically it will not be possible for BMC to go and inspect each pothole every day, but the concept of crowdsourcing was used here, okay, and technology. So, but people in your neighborhood every day you see that, okay, and you can easily take a picture because these days the smartphones come with a lot of high powerful cameras, and they have a GPS tagging. So you take a picture of the pothole and upload it to the site of BMC. Okay. So once this is done, so the basic data acquisition, which was an issue with BMC, they were not able to every day know where the pothole is cropped up, where there is a crater. So the data acquisition part was taken care. Okay. Once you have the data, you were able to devise saying that, okay, we need this many personnel to go to this area to be able to fix it. This is the material we require, and this is the equipment we require. and this can only be done in the night time when traffic is fairly thin. So from midnight to morning 6 o'clock or 7 o'clock, they finish all this work and come back. So it's a wonderful thing. So we have technology, we are able to get the data, and when we pass on to the data, they segregate which area, which place and all that, and they allocate the resources, manpower, equipment, and things get sorted out pretty fast. So this is a collaborative use, how data can be used in a crowdsourced manner for public good. Okay, so enough. I have given some background of data. We'll now move over to a little bit about the supply chain domain. Uh, so the supply chain domain, let me tell you how this supply chain started and all that, okay? So the supply chain is nothing but previously, during this industrial revolution, there was one shift which has happened, and that is use of machines instead of muscle power. So previously, animals and muscle was used to drive or do anything. So with steam coming in, with oil being discovered, so things started there. That was the starting point. From there it has emerged and all that. And now, initially when there were companies which put in money to make products and all that, they were all vertically integrated, meaning there were giant companies like Shell and all that, who right from excavation of material till providing the final product to the end customer, they were doing everything under one management and under one organization. Okay, so they were controlling everything right from extraction to that. Okay, then legislations kicked in. A lot of government saw that these organizations are becoming very, very powerful, and they can do whatever they want to if they are not regulated. So they were broken into small pieces, saying that no, there has to be competition, and without competition, you'll not be allowed to operate. Now, as a result of that, the big company has now been broken into small pieces. Okay, and during the 1990s, you must have heard about persons like the concepts like core competency. Hamel and Prahlad, C.K. Prahlad, strategy guru C.K. Prahlad and Hamel and all that, they came up and said, no, you should only do whatever you are best in doing. That leave the rest to other people. Okay, so you should focus on your core activities and outsource the other activity to other organizations. So if you look at that, the big organizations were broken into small pieces, and people kept the core part which they are able to do of their own, and remaining part they said, okay, let's give it to someone else. Okay, now once that has happened, now how do we now we have one organization has been probably broken into, say, now 50 organizations or 20 organizations. Now if there is the simple law of differentiation, if you have broken down a thing into many pieces, then you also need to integrate it, you need to stitch it, okay, to be able to use it. So if I were to provide service now, say automobile, to an end customer, then I have to rely on the mines people who are excavating and then getting the iron ore, okay, so that I can make my frames, chassis, and many parts. Similarly, I have to rely on people who have rubber, okay, so that I can make the tires. I have to rely on people who make, say, casting or a forging, okay, or I have piston rings. So various components. So people started specializing different parts. Now the OEM, say for example, you have, say, Toyota or Honda or Maruti or any other car manufacturer. What it does the tying up work. Okay, so it establishes some amount of partnership with these companies, and based on that, based on certain agreements with respect to how much quantity and what quality of products they are supposed to give, these suppliers will supply those products, and the OEM will try to manufacture the final good which is required and then pass it on to the end consumer through a distribution network. Of course, there will be distributor, retailers and all that. They also come into picture because they provide after sales service, they talk about warranty claims, and they also give additional value which the OEM is not able to provide. So based on all these things, finally a product or a service is given. Now, if you look at, there has to be a delicate balance between how these different companies should coordinate themselves. Okay. Now, if they do not, then there are going to be a lot of inefficiencies. If there is one link which is broken somewhere, suppose, say for example, in 2011 or so, there was a tsunami in Japan. Okay. And that caused some 150,000 units of loss for Toyota. They were not able to manufacture those products because certain suppliers and other people were affected by that storm. Okay. So this could be, so that this is a natural disaster which has upset the supply chain. Similarly, there could be quality issues which can upset the production. So for example, you have to manufacture 100 cars a day, and somehow, and each car requires 4 tires, and you have only 200 tires. If you have 200 tires, of course your production line will not be able to roll out the 100 cars. It will only roll out probably less cars. Okay. So they have to work in sync. So Forrester, I think you would have read all this. So essentially Forrester, J.W. Forrester was a MIT professor, very learned person, and he has in 1958 he said that the flow of information, material, money, manpower, and capital equipment
You have to be careful
will.
about sometimes unknowingly the mic is on.
Yeah, sorry. Sorry, I could not hear that. Am I audible? Okay, let me continue. So it said that these flows will determine the decision, policies, organizational form, and investment choices. Okay. So in 1982, so there was a consultant from Booz Allen named Oliver. So he coined the word supply chain management. And essentially what I described, from raw material to supplier to OEM, retailer, customer, the picture depicts this. So if you look at, there are 3 flows which are important. One is information flow, there's a goods and service flow, and money flow. So from the customer, there is flow of information, money, and from the suppliers, there is flow of goods and services. And Epix has given a definition of supply chain which says the design, planning, execution, control, and monitoring of supply chain activities with the objective of creating net value, building a competitive infrastructure, leveraging worldwide logistics, synchronizing supply with demand, measuring performance globally, is supply chain management. Okay. So what is the purpose? Purpose is simple. In any corporate, it is value maximization, how much profits I'm going to make with, and how much competitive, and how long I'm going to survive. So in the short run, you're looking at financial gains. In the long run, you're looking at competitive advantage and sustainability. Now, I'll go a little fast because we have to cover a lot of other cases. So I'll go a little fast with this part. So what are the components? There are 3 components. One is you need to have a network structure. There has to be business process, and there has to be management components. Now, network structure, we talked about it. This is a focal form, and then you have suppliers. So supplier can be N suppliers. Then on the right hand side, you have the customers. Okay. So on the customer side, there is a demand. On the supplier side, there is the supply. So there must be a demand and supply match to be able to meet goods and services. This is the whole idea of supply chain. Now the next one is business processes. So if you look at it, previously there were all, if you look at, this is a manufacturer in the middle, then you have suppliers, okay, supplier tier 1, tier 2 supplier, and on the other side you have the customers, okay. Now previously it used to be departments, okay, purchasing department, sales department, finance department, and this was right because at that time when industrial management, scientific management started, Taylor had said that division of labor gives you a lot of efficiency, so people started making departments, okay. But there is an issue because those departments, he had said that the department heads will resolve any issue which is happening, which is the collective objective of the firm, okay. But those things over a period of time, due to power centers and all that thing, that didn't work out well. And in today's world, when the people want things faster and there is seamless no requirement of products to be and services to be provided, these siloed working will not help. So there are these processes which are related to customer relationship management, supplier relationship management, demand management, order fulfillment, manufacturing flow, that is production, how production happens, product development, that is new product development and commercialization, and returns. So these are some of the 8 processes given by Douglas Lambert, okay. And then he has given the management components also, planning and control methods, organizational structure, communication, product flow, the management methods, the risk and reward structure, power, culture and attitude. And then we come to, this is called the SCORE framework. So when supply chain started, there were 2 leading groups. One is the Lambert group, which created CSCM. So they created a body called Council of Supply Chain Professionals. And there was the Supply Chain Council, so which has come up from consultants PRTM. There was a consultant called PRTM, there was MIT, and there were 69 other corporates. Together they formed the Supply Chain Council, a no-profit organization, and they came up with this framework. And this framework is the most widely used framework in the world for planning your supply chain, designing your supply chain. So it is very simple. There is a planning aspect, and source is your purchasing from your suppliers. Make is what you make, produce, and deliver is what you give it to your customer. And from customer side, if there are returns, you return it. From your side, if you have to return to supplier, you do it. This is a very simplistic top level view. You can drill down to level 2, level 3 and all that. You can look at the website of Supply Chain Council. Actually, it has now changed. In 2019, they have become ASCM, okay? So Association of Supply Chain Management. They have changed the name and all. Actually, Supply Chain Council merged with EPICS in 2014, and EPICS has now converted into ASCM in 2019. Now, what do they say? They say that, okay, there are some long-term activities, there are medium-term activities and short-term activities, okay? So I will not spend much time on this, but just to give you that from procurement, production, distribution, sales, okay? So if you look at source, make, deliver, those things are procurement, production, distribution, and sales, okay? For each of them, there is some long-term activity, some medium-term and short-term activity. If you do all these activities synchronously without any hitch within the organization and with your suppliers, you will be able to perfectly provide a product and service. Now, based on that, there are some IT solutions. So why I was driving this is this, for each of these, say supplier selection or plant location selection or a distribution structure or sales planning or distribution planning, it is not made just like that. So it is made with the help of lot of specific planning tools or planning software, and they rely a lot on data, okay? So for network planning, you would require a lot of data related to availability of land, availability of supplier, availability of bill of distribution. So from where to where, okay? And how I will reach to my market, and what is the cost, what is the distance, are transportation modes available, okay, can I ship it through do I need to air freight it, or there are 4 or 5 methods, can I go by rail, is it accessible by ship, or it has to be by small trucks, is there any restriction? So a lot of things which will make my bill of distribution decisions. And then if I put my network there, at the end of it, I should be able to do a calculation of what is my profitability, what is my market share, and whether it is giving me competitive advantage, whether I'm able to garner something more. So those decisions. So a lot of data points are required to do it, and there are softwares which do it. Similarly, master planning, purchasing, I have some slides on them later on, just to give you saying that there are planning systems sitting there which will work on a lot of data, okay, lot of master data as well as lot of transaction data to be able to provide what a company should do and how a company is run. So supply chain management is more about planning your activities and executing. So for planning, how you plan what to make and where to make and how to distribute and how to service your customers. So the entire planning gamut, as well as after you plan it, you execute it. So how you execute it. So most of the, if you look at it in this matrix, most of them are planning, except for scheduling and transportation. So these are the things I can plan a lot of the thing, but when I put it into production, I have to schedule it. So that is a kind of execution happening to my plan. Similarly, after I create some products, I should be able to transport it, distribute or transport it. So transportation requires physical movement. So this is a execution. The rest are all are on paper. I do it on paper, do it on calculation and all that. But these are the two things which are no execution oriented. And then of course there is this customer feedback. Customer service is again execution, because you are dealing with customers who have complaints or who want to give you a feedback or something. So there is again some amount of interaction, and there is a physical thing which is happening, which is execution related. The rest of all are planning related activities. And one thing we need to know very clearly is supply chain always matches the demand to the supply, and it is this balance which helps keep profitability, keeps efficiency high. Now there is a phenomena which was uncovered by Forrester and Lee and all. So they found that, and they term this phenomena as bullwhip, which says that if there is a small change in demand, say for example, customers were asking 100 units of a particular product. Now tomorrow they ask 105 units, 5 units change only, not much, okay? Then as the information progresses from different layers or different players in the supply chain, there is a tendency of that 5, that small spike, to amplify as it progresses in the supply chain, okay? So when it comes to the warehouse or distribution center, warehouse is okay, retailer or warehouse, and here it is wholesaler distributor, and here it is the plant. So when it comes to plant, look at the small change here and look at the small change here, because it is not coming instantaneously. That information is not available to all the parties instantaneously. There is a change, there is a big lump, okay? So they found it, and there was an interesting story about it. About Pampers. So P&G produces these Pampers for kids, and they found that the rate of consumption of Pampers by end user, that is the babies, is pretty much steady, okay? But then they found a lot of fluctuations with respect to the production and distribution of Pampers, okay? And then they realized that it is due to bullwhip effect, okay? Because information which is being passed from here to here, here to here, to in the entire supply links, it is time coming at different points in time, and it is getting amplified. So and there are a lot of studies on bullwhip effect. If you want to study, it's a very old phenomena, but if it is not handled properly, it is going to do a lot of damage to the efficiency and effectiveness. So this is the impact of supply chain on return on assets. So typically when you measure, there are some financial measures how the company is doing, whether it is whatever money we have invested is giving us good returns or not. We find that out. And it's a simple formula: revenue minus expenses, or whatever your sales minus the cost of goods sold divided by the total assets. What is the amount of, so that is the ROA, that's the formula. And how revenue is getting impacted based on demand planning and production planning if they are not in sync. So demand is something, production is doing something. If it is not in sync, then it will result into unnecessary purchases of item. It will lead to excess raw material inventory as well as excess finished good inventory. If this is happening, then it will impact your revenue negatively, because your costs will increase, expenses will increase, and so revenue minus expenses will get down. Even if you are not producing as per what is required, then you will not be able to sell the product despite there being a confirmed order. You will not be able to give it to the customer to realize the money. So you will lose your top line, your revenue, and you would have produced another item which is not required in the market, and you are holding it as inventory. So this is a double whammy. So demand and production has to be synchronized. Similarly, production plan and purchasing plan, whatever you are producing and whatever is your purchaser buying material from supplier, that needs to be synchronized. Otherwise, you will be stuck with your production line not producing the amount of quantity of product which has been required. Okay. Similarly, production plan and capacity plan. Now, suppose you have a production plan of 100 units, your capacity is only 50. You will not be able to do it unless you add capacity in term by increasing your facility yourself, or you outsource it to some other person who has that capacity for a fee. Without that, you will not be able to meet your targets. So synchronization of demand with production with purchase, and production with capacity is pretty important. Now these are IT systems and data that is being used. Okay, so to get all these things done, there are POSs, point of sale system. When you go to any market and all that, there is people read it with a scanner. So that's a point of sale system. It is connected to the cash register. So they don't have to find out what is the price, how many quantity and all that. You just have to scan it, automatically shows on the screen. Then this barcode also in 1950s or 60s it came, stores a lot of information. RFID is same, is radio frequency identification. GPS has made lot of services like Uber and all that, which are place specific to offer. Then you have internet connectivity, EDI, ERP. You can go on list this. So these are all certain things which are being used for in SCM. Now, what factors are impacting? There is this globalization, okay, and specifically these days we are looking at sustainability. The ocean temperatures are rising and all that, and there is the global pandemic currently last 8 months. That is also impacting because China was one of the biggest source of raw material and finished product for many economies. That probably will undergo change, not because of efficiency reasons, but because of other reasons. So the way the supply chain was wired is going to, or configured is going to change, because some of the work which China was doing will get moved out to other places, or the manufacturers will reshore it back. They will get the work back to their own place where they can have more control over how things are done. Then customer side, customer is ever demanding. Okay, whatever was the place. Remember, there used to be a waiting time of, when I was a small kid, there was a waiting time of 6 months for a Bajaj Chetak scooter. Today, I don't think anyone will wait 6 months for a scooter or a scooty or anything. So the perception of how much time people can wait, what kind of quality, what kind of service offering, that has gone to a radical shift in last 30 years. And then technology wise, we have already talked about it, don't want to talk. And then competition is also cutthroat. Now let's look at some of the applications. So the use cases area in supply chain management are network planning. We spoke about this in quite detail about how to do a network, demand forecasting, demand fulfillment, master planning, distribution. So we'll see some of them, and we have about 15 minutes left, so I'll quickly go to some of the case studies also. So this picture we had seen, and here how data flow should convert. So everything starts from the demand side, okay, from the customer. So if there is no customer, there is no product and service to offer. So everything has to be from in the supply chain. Customer is the king. From customer side, whatever information is generated with respect to demand, that gets planned, that gets passed on to different other planning systems. Okay, so from here there will be in demand itself, there will be some forecast, demand forecast, and confirmed orders. Based on that, there will be some master planning which will happen. Based on that master planning, there will be a distribution planning, there will be a production planning, and there will be a purchase or material requirement planning, MRP. So demand planning and master planning are some of the major areas of from a planning efficiency point of view. Okay, because they drive other plans. Production plan is driven from master plan, distribution plan is driven from master plan, scheduling is done based on that. Okay, and this master planning is done month on month. Okay, and production planning is also done every month, distribution planning is done every month, scheduling is done on a daily basis, sometimes weekly, hourly basis. Transportation is planning is done on a daily basis. Okay, and this network planning, how to put your factory, how to put your delivery network, distribution centers, and how to source your supplies. This is the network planning. This is done once in maybe 3-4 years when situation changes. Okay, we see that there's a lot of change in the physical environment, and a lot of other providers have come in, other suppliers have come in, or there is a government regulation. Then it will require strategic network planning. So for example, now GST has come in 2017. So GST was the octroi and the taxes were based on certain state boundaries. If you cross this boundary, you have to pay tax and all that. But those are no more true. So people used to say, for example, in Mumbai, whatever goods used to come, all the warehouses are located some 40-50 kilometers away in a place called Bhiwandi. So everything will come and stop there. Okay, and people will only get it inside Mumbai by paying the octroi and other taxes only when there is a sale to be made. Otherwise, they keep it there. Okay, so but now that restriction is removed, so you can keep it anywhere. You can bring it to Mumbai, you can keep it anywhere, or wherever you want, you can put your. There's no restriction on movement of goods anymore. So that will cause for strategic planning. Okay, now let's look at demand forecasting. So when you do demand forecasting, so you have to do it on product dimension, customer geography, and time dimension. Meaning what product, say for example, you want to sell a Maruti car, okay, say Ertiga or something else, then whether it is petrol or diesel version, what product family it is coming from, and what variant within that XYZ and 1,000 other variation with color and all that thing, they give product dimension. Geography, you are selling it in Delhi NCR or in Kerala or in Madhya Pradesh or Gujarat, which area it has come from. And time dimension, when you want to sell it, it is required now or after 3 weeks or 2 months. What is the, so it is looked at in 3 dimensions. So the data needs to come in these dimensions for us to be able to take some action. So this is where I have told that the data tagging has to happen, and appropriate data has to reach. And there are different approaches followed by different organizations. So if you look at it can be divided into, the country can be divided into entire country, then state or region, northwest, east, central region, and each region can have state offices, and state offices can have area offices, depending on what is your service level and how you can do it. People look at it, and the forecasting happens in top down and bottom up, both method. And I don't want to spend too much time, but this is how a typical planning happens on a monthly basis. So day-wise calendar is created. So this is also called a dial-up, day in the life of a planner. So if there is a planner who is doing demand forecasting, then they adhere to some kind of a schedule, and different, there are, if you look at it, these are swim lane diagrams. There is a planner who creates a statistical forecast for 12 months, passes it on to area office talks to sales office, they have a consensus, and then they send it to, it comes slowly up, okay. Area office and sales office, state office will have some consensus, that number gets updated, goes to regional goes to head office, then the forecast is frozen. So there is some, it is not that pure only data is coming, data, and there is a process, people put their thinking into it, and then sanitize those numbers, purify those numbers, then agree, and as a team they will now go and try to get those numbers, okay. So this forms, so once it is frozen and all that, then this forms the input for master planning. What is master planning? I'll just give you, will not read all this. So if you look at it, suppose a company has got two plants, plant 1 and plant 2, and there is one supplier, or maybe you can have many suppliers, okay. So your product, whether you want to do it in plant 1 and plant 2, that is a decision you need to make. Now how will I make that decision? Suppose my customer 1 has placed an order, so do I do it in plant 2 or plant 1? So it all depends on, the master planning determines where that product will be made, so that the overall cost of production, overall cost of distribution, and the timeline which we have agreed with the customer is met, okay. And also that gives us the highest profitability, or whatever we have set the criteria. So this, so we have only 2 plants here, but there are companies which have 15 plants, 20 plants. So they have to determine where they have to do it. So for example, there is a product which has, quarter by quarter, the demand is 12, 13, 10 and 45 units, okay. But the capacity available is 20 units, that's the total. So if you don't plan it properly, you just make whatever is required, then in first table you get to only 35 units, you are not able to satisfy that order. But because if you look at it, there's a big lump of 45 here in quarter 4, then you have to build ahead. If you build ahead, then only you will be able to meet it. That is why this solution on the right hand side, table 8.3, they are building ahead to be able to meet that particular peak. So if you know the forecast, okay, how much is going to come, okay, then you can do, you have the capacity, within that capacity you will be, that gives you an option to plan it and be able to meet the demand. If you are not able to do it, you just do whatever is there for that particular month, probably you will not be able to meet up, or you will lose some sales, lost sales, okay. So planning is very important, because this one side, it shows whether you should be able to meet your demand, all the demand, and second, so by building ahead if required, and second is you will be able to do it in the most efficient manner, okay. So there are trade-off decisions that are being made for master planning. Similarly, master planning also has got some kind of process. We'll not go into it for lack of time. Similarly, production scheduling. So there is, so what is the demand picture with due dates? Here, when that order needs to be specified, in what lots, am I making it 1 at a time or 20 at a time? What is the lot size I need to do? What is the availability of machine? What is the availability of raw material inventory? So all these things will decide how I create my schedule, okay. Most of the time it is based on a heuristic, okay, because no, you cannot solve these problems entirely by brute force method. So we apply a lot of heuristics to be able to solve these, like genetic algorithms or ant colony optimization, swarm particle optimization, etc., to be able to do the scheduling part. Okay, now there are some seminal studies which have been carried out, and those would not have been possible without data, and that have changed the course of a particular industry in the supply chain. So in the mid 80s, there was Kurt Salman Associates was a consulting firm that was engaged to study why there were a lot of inefficiencies in the apparel industry in United States. Okay, so they found that the average lead time for raw material to end customer, so entire cycle time from getting the raw material till you sell the product to the customer is 66 weeks. So 1 year is 52 weeks. So this is 66. So it is more than a year. Okay. So a year and a quarter. 5 quarters is the time that it took on an average. And they further studied and found that the manufacturing time was only 11 weeks. 40 weeks was in warehouse. And every store, it waited for again 5 weeks. Now, during that time, 80s and all that, it was more of not a pull way, it was a push system. Okay, they thought that you produce whatever you can produce, and then we'll convince people, we'll give them discount, we'll do advertising, we'll do promotion and all that stuff and push those things out. Okay, based on that, because these are all apparel is, you know, sometimes fashion comes in, then if it is not there, it goes down. So you have to do a lot of discounting and all that. So markdown was 14 billion. Stockouts, whatever you wanted but is not available, is 6 billion. And whatever inventory you were carrying were 5 billion. So $25 billion was the annual loss which was calculated. Now this would not have been possible without aggregation. If you look at each shop, then you will find, okay, this is how the industry is doing. But they were able to aggregate all these data to be able to figure out that there is an issue with the lead time. Now, how you can crash the lead time, then you will get those benefits. So this is the amount of data. They didn't have data science at that point in time, but they used manual methods to be able to get the truth out of the data. Today we have much more sophisticated system, but rudimentary, the concepts are same. It is only that even now I am using, suppose I am using a spreadsheet or a computer to do my calculations, which I have learned in school. Maybe I was adding on a pen and a paper. I was doing that. Maybe I was slow. A computer can do it fast without error. Maybe I can do error. But the concept is the same. But applications become faster and you are able to process a lot amount of data. That is what has come in data science. Now, after this diagnosis, there was a quick response movement which has started. And what they used, they said, okay, we'll have to share information with our supply chain partners. We'll have to use barcodes, we'll have to use point of sale. And the point of sale information can be used to drive the information. And then electronic data interchange. It means that you have computers in your organization and your supplier organization, and you agree on a common format, and these computers will talk or exchange data in that agreed format. And you streamline your processes. This is what. So after that, the apparel industry has changed. We'll see a case study of Zara. So how they are doing. Then there is this ECR. Here again, the dry grocery supply chain, an annual saving of 10 billion was shown because people worked in forward buying practices, etc., and which was not reflective of what was the customer demand. So again, here also they said, okay, you have to have point of sale system, you have to have manage your inventory, you have to share this data between this manufacturer, wholesaler, retailer. These people have to share information using EDI, and these are the things that needs to be done. So this is all. We'll go quickly. We'll just finish. And it spread to Europe also. In Europe also, they showed within a 10-year period, they showed 18 billion or 3.6% of the sales was the benefit which was shown. Next is, let's go to Walmart. Okay. Walmart is one of the pioneers of supply chain. They figure repeatedly in Gartner's top 25 supply chains every year that is being produced. It's founded by Sam Walton in 1962. The revenues is $512 billion. They operate in 27 countries, 11,000 stores, 70 countries. They have suppliers, and at any point in time, average inventory they manage is about 32 billion. So what they did, so they did some interesting thing. Okay, right from that point in time, they have done something on data collection part. So, and they have tried to use that data. So in 1975, they leased the IBM 370 in 1975. When people were not using, they were had the foresight of leasing some computers from IBM to be able to connect their stores and distribution centers, capture the inventory. Then they used company-wide barcode. They made it mandatory in 1987. Then how to communicate? There was issue with communication. There were not many satellites during that time. So they spent money in putting their own satellite. Okay, they said, okay, we need our own satellite to be able to do that communication. How many companies will think of putting a satellite? Probably very few. Then they created a huge database called Retail Link in 1992, which captured all these data and used and was connected to their satellite, connected to their vendors, and gave the positions of inventory, sales trends, etc. Okay. Then they had EDI. They were transparent and they shared information with their suppliers, because Walmart is the end retailer, so it is getting all the information from the customer. They are pushing up down to their suppliers. Okay. Then in 2004, they mandated their top 100 suppliers to go for RFID. Okay, it was kind of a diktat. They tried to force it. People were not willing because RFID was not a proven technology by them. The expenses were pretty high, but still they went through it. Okay, RFID helps pallet level tracking. All the items that are in a pallet get scanned. So, and it helped Walmart and P&G. A lot of things have happened between Walmart and P&G in their collaborations. So it reduced their inventory level by 70%. Okay, and increased their service level to 99% from 96%. In 2000, fast forward to 2015, they spent about, when Amazon came in and was taking their market share, Walmart was only on the physical side. So they have now turned their attention. Maybe they are a little late. That's why Amazon is eating away their e-commerce business. So in 2015, they pumped in about $10 billion to create e-commerce capability. Now that is the capability one part, and then to be able to do or service all these things, whatever they are doing for execution purpose, they have their own fleet of trucks. They have their own drivers which are non-unionized. Their DC and store distance is about 130 miles. So average speed in USA is about 60 miles an hour. So in 2 hours, you can reach from your DC to your stores. And they practice certain things called cross-docking and all that. We don't have time, otherwise I would have spoken much about it. Then there is something called other practices called vendor managed inventory, which means that whatever information, so vendor managed inventory is you give a small space or a shelf to your supplier saying that this is my store, this shelf is yours, whatever is being sold, you have to replenish. I don't have to tell you what order to come, but I don't want to lose any sales. So P&G, suppose they put their diapers or soap or whatever, they are given a space. So they will, whenever there is a sale happening, their P&G will get a signal saying that, okay, something has depleted from the shelf. So immediately P&G will come and replenish that shelf. So vendor is managing that inventory. So it's called vendor managed inventory. Okay. So that's a very revolutionary concept, because in olden days, the argument was arm's length or adversarial relationship with supplier. But this is a very cooperative and collaborative arrangement with the supplier. So they followed these cross-docking, and everyday low price was the strategy. So if you go, Walmart thrives on volume, and they make wafer thin margins. Margins are 1%, 2%. But since the volume is $500 billion, they make a lot of money out of it. Okay. Now we'll talk about two more case studies, which are mostly in India. One is this Escorts Agri Manufacturing company. Now, so they implemented. So when I say when they implemented supply chain in 2009, it means that they tried to figure out what is wrong with their data and what managerial decisions they were not able to make and how they can make it. Okay, so they were trying to So when you get the data, your organization also has to prepare itself to receive that data, and that is where you need to put the structure and process in place in your organization and in your suppliers organization as well. So they were having problem with lot of disconnect between production and demand. That was their problem. And they had both high raw material and high finished goods, meaning they were producing which the market was not willing to buy. That's why, so there were high inventory on finished good and there were high inventory of raw material because there is something wrong with their planning process. So this was done. I can tell you that I was part of this particular initiative from the supplier side. So I too was a company which gave these planning solutions then. Of course, the data I am showing you is not from my own experience, but it is published data which Escorts has published in CTO forum in 2010 called Unlocking the Fortune Cookie. So I'm not giving any customer confidential information here. It is all public, there in public domain. So it caused a reduction of inventory by 40%. How did they do it? No, one was the demand planning was sorted out. Demand was not happening. They had issues with demand planning. So we put a process. They didn't have, at that point in time, no internet connectivity was an issue for their 32 sales offices, and they had 150 odd salespersons. So for feeding that data, etc., there was an issue. So we sorted out that data first. First point is the demand part. So demand part was sorted out with IT infrastructure being boosted and the capability of capturing the data. Once that happened, we focused on the factory part. On the factory part, there were a lot of things which they were doing. So there is something called sales and operation planning. So that sales and operation planning was not happening properly. So now they have correct data on the demand picture. Now they should be, so that picture was given to the factory side saying that we need these. Their previous KPI was how you have to maximize utilization of assets, meaning my factory can produce this, I'll produce that much. So the KPIs were different. We said, no, those KPIs will not work. Your KPI has to reflect what is there in the market demand. So you have to produce what is required, not produce to the capacity of your plant. And then we also said that you have to rationalize, you have to have a discussion with your suppliers and shorten the lead time. You have to have a discussion with them and reduce your lead time. So lead time was reduced. Based on that, they don't have to hold that much amount of inventory in their physical position. Okay. So raw material inventory was reduced by 40%. And finished good inventory, again, they were sending, their distribution was wrong. Wherever they had to send, they were not sending properly. So wherever there was a demand, there was no tractors available. Wherever there was demand, no tractors were available. And where there was no demand, tractors were just lying there, and they were getting rusted, corroded, and then after 3 months, if you are selling that tractor, you have to do refurbishing, spend a lot of cost to make it again sellable. So those issues were reduced, and finished good also was decreased. And the productivity increased by about 6%, 6 to 8%. And they had the capability of now forecasting. So this is based on data. Purely everything that has been done on data on demand side. So data on demand side were captured, processed, and used scientifically to drive the production. Then there was discussion with your suppliers to reduce their lead time, and then the rationalization of some the suppliers happened. Then share of business for each supplier was fixed. Based on all that, there was some efficiency which was gained on the supply side as well. Next is shopper stop. Sorry, I'm exceeding little time, but I have few more slides. If you permit me, we can go, or if you tell me to stop, then we can stop. Can we go on for another 5 minutes or so?
Yes, sir. We can continue for another 5 minutes.
Oh, okay. Thank you. So similarly, this is again one is shopper stop. So Shopper Stop is again a big retail format. Now the challenge they were facing is again same thing. In their stores, either there was overstocking or understocking, okay, because they followed some kind of a standard stocking norm, okay, which was not true, because you will have fast movers, you will have small movers and all that, and different categories for children, for women, for men, and different time of the year, the clothing, etc. change, and depending on the location of the store. Suppose you are in an upmarket store, then though the assortments that need to be carried are different from a different low income group. Okay, so they implemented a supply chain solution. So it's called merchandise manufacturing solution and a assortment solution. How your assortment? So retailers work by assortment and planogram. How your store should look like, where you position your stock, so that when I enter as a customer, first thing is that it attracts me. So those kind of activities were done, and what kind of products you need to carry where. So those were sorted out. Okay, and then how you can, based on the information available at different DCs and stores, you can also transfer one stock from one DC, one store to another store if it is not selling and all that. So those will also help you improve your sales pipeline. So this has resulted in 12% increase in sales at the chain level. Okay, this is the Zara case study which I was talking about. Zara is a leading fashion for women. So they target women in the age category of 18 to 35 or 40 who are typically office going, and they need the style statement is not very exaggerated, but there is a certain requirement for that. So it's a very big company, and it also figures. So Inditex is the group. So if you look at Gartner top 25 list, Inditex will figure there. So, and if you look at the spread, the amount of products they produce and sell and all that is phenomenal, and they are the best in terms of the fashion industry is concerned, fashion apparel industry is concerned. So they are the almost on the top. So how did they do it? Of course, they used a lot of data and all that, but they also used a lot of, with that data, they also build a lot of processes also. Okay, so we can look at the 4 processes: a product organization, how designs were created, because this is a fashion, so it is related to concepts, new design and all that. Once you have to create a design, second you have to figure out how to translate that design into a product and get it to a store. So that's, if you can do these 2 things right, then you will be able to sell your products. So let's see that. Now they have no product, very creative in-house designers. Okay, there's 3,000 people who are working on different designs, and they create. And essentially there are 2 sale seasons which they use. Okay, 2 collections are created per year, and the designs are made contemporary. And once the design is created, they have to get it into the store in about 4 to weeks time. Okay, so if you get it in the time of the sale, you catch the people, and the sale continues for about 13 or 14 weeks. So you have time to cycle it 3 times. About 3 times you can get your collections, new designs, and show it, and the same customer will come and buy 3 times. If you are not quick enough, then if a lady buys one particular dress, maybe she will come and check after 6 weeks or so. If she doesn't find a good design, new design again, she won't buy, because the existing design is with her already. So they try to capture to that specific need. Okay, so during the season, so they catch hold of about 20-30% of their designs and push it through. And once the design starts, they have the capability of creating those design, translating those designs and getting into the shop, okay, within that period. So this results in markdown So unsold inventory is about 15% for them. It is not that it is zero. But if you look at it, for competitors, 50% is the markdown. Whatever they are producing, they have to mark down, they have to give a discount of 50%. But for Zara, it is only 15%. So that shows that whatever they have quickly, the agility of their supply chain is what is giving them the edge to command that premium price. Okay. Now this talks about how they are going sourcing and all that. A little detail. We don't have time, so I'll skip that. This is about the production facilities. This is distribution. Okay, they use a lot of technology and data. Like their distribution center can handle 45,000 garments per hour. So when the distribution center, it comes from the supplier, so it is there with them. Okay, they put it in the DC and it stays in the DC for 2 or 3 days. Doesn't stay more than 2 or 3 days, and it has to be immediately sent to the stores. Okay. So they were getting so much of sales that they have 45,000 garment sorting and placing capacity per hour. That's the kind of strength they have built in. Okay, this is again okay. From the retailing perspective, okay, they have separate line for women, men, and children. For women, it is again by fashion, age, and price. So they have segmented it. The products are segmented to this kind of level. Now, without again some kind of planning activity that happens for these, it is impossible to get within that time frame. So this is where a lot of data science and activities they are already using. Okay. So, and their average customer visit per year is 17, which means that every month more than 1.5 times. Okay. So people visit on an average. So you cannot visit half a time. So probably every 2 months, 3 visits are made. Okay. And they don't advertise. Okay. Their advertising cost is 0.3% because people know by now, they know Zara's brand name, and brand name is pulling them, and markdown is less, and they target income is middle to high, and women between age 18 and 34. So this is how they've been able to get their stuff. So with this, we will conclude today's session. If you have any questions and all that, we can do it, or you can send me a query and all that. I'll be happy to answer. My mail ID is srichandan.sahu@gmail.com. So if you want, I can write down here.
Sir, I don't see any query in the chat box.
Yeah, there is no queries. So if you have any questions and all that in future also, if you want to connect me, you can always drop a note to my mail ID, and I'll try my best to return to you as promptly as possible. Sometimes it may not be, it may take a week or so also. But do give a reference saying that we met in this FTP, and with that you have raised this query. I'll try my best to answer, and if I do not have the answer, I will point to you to resources where you can go and find for yourself. So this is all from my side. Thank you for providing me this opportunity to share from an application perspective what data science can bring to supply chains. So if you have any supply chain data science related questions and all that, so please feel free to mail back to me. And I hope you would have had some perspective of supply chain and business in general. So I didn't delve into the technical nature, but it was more on application part. I hope you did learn something. Thank you very much.
Thank you, sir. Thank you. For me, it was really an informative session. I wish we'll have some this type of session in future as well.
Okay.
On behalf of our department and the organizer of this particular activity, I'd like to thank you once again for accepting the invitation and putting forward your experience, vast experience in the industry, as well as the research in the particular domain. So I once again thank you, sir.
Okay. Thank you so much. Thank you for inviting me. So I wish you all the best to all the participants in their career and life. Bye bye.